I'd like to take a few minutes of your time to explain the advantages of this new era design so you understand what we're accomplishing here and how it addresses and exceeds your regulatory minimums. We did furnish with the submittal the book Proferbia. If you want to find out much more information than in this video, I would highly recommend you read the book. Your regulations, as well as any in the world, start out with a purpose and intent. Gastonia's regulations, their purpose and intent, is quite comprehensive compared to what we usually see. But what follows the purpose and intent to make sure those goals are met, just like any other ordinance on the planet, a set of minimums. So what's going to happen is the designer is going to try and jam as many units at minimums onto the site with some disastrous results. It's not going to accomplish the purpose and intent, but this is the way regulations are written. And what ends up is this neighborhood. This is the actual before plan that we had put into the computer to get better numbers out of it. And you could see there's 32% or 32.6% of the site is man-made elements. There is some things wrong with the plan. For example, they had homes built under power line easement. There's utilities going through it. But for purposes of this presentation, I just want to show you the before plan that we began with that had 4,820 linear foot of street. The geometry of all growth is trigonometry. And when you look at before computers, when I started in the business, I would put an arbitrary coordinate on a piece of land, look at an angle with a protractor. No computers. In my head, I had to add up all the distances to get the total distance of lots. Then you would look at the log table, find where the sine of that angle was, take the number that was in that log table times the distance to get the difference in the north coordinate to get the northing of the next point, and then you would do the same thing with the cosine and multiply that to get the next coordinate. That process, without a mistake, was about 5 minutes. If you had a curve, it got more complex because you would have to have a direction or a tangent into the curve to set a direction to the center point, calculate that, calculate the end point, and that would be very complex. If you had a non-radial line, that calculation would be about a half an hour, which is why regulations mandate a radial line from the curve of the center point so that someone in the city 50 years ago didn't have to take a half an hour to plat check it. So all lot lines had to be radial or perpendicular. That's still in ordinances today, even though this plat checking business has gone away. What about technology? Well, today's technology, you simply put the minimums in a sidebar, snap your mouse, and lots appear. It makes a subdivision like this. For example, this one's even more complex. It has curves, it has radial lines, it's going to have a cul-de-sac, 162 lots in 3 minutes flat. Every one of those lots are going to meet your ordinance, so you will approve it, even though it might not be a great place to live in. When we take a look at the design and what was accomplished, I want to talk about the bad parts about this normal planning process, which is unintentional waste. So what do we mean by that? When you look at the typical gridded straight line developments, what you've got is typically a lot of street that's side loaded. In other words, a home's fronting one side, but it's not fronting the other side. So it's 50% utilization of the street. And the street isn't just the pavement and the sidewalks that's 50% utilized. It's the right-of-way that's dedicated to the city, making every lot smaller. It's a financial hit for the homeowners because 50% of these streets aren't needed, and what means is that the likelihood of the price of each one of these homes going up somewhere between $10,000 and $20,000, the sales price can be traced right to this waste. Now, in order to advance growth, you really need to think differently and not work on automation to do the thinking for you. So, this is why we teach. We're looking at the awareness, the human intelligence, and that's not pressing a button on a CAD system to do the thinking for you. So it's a new form of geometry. And I just really want to talk to you about the logic behind it. So this is what we call coving. Before coving, just as an easy way to think about this, that bubble in the street, why did they put that there? It's because this is in Omaha, the ordinance is 20-foot front yard, so they want to get an extra lot in there. So in order to get the extra lot, you stretch the setback line, but the ordinance said 20-foot front yard setback, so you have to build that incredibly expensive piece of pavement to serve that extra lot. But the ordinances never said that. That's how it's interpreted. The ordinances will allow you to go beyond the minimums. So you didn't need that big piece of pavement. It's this idea that you could break the relationship of what's happening with the street, the setback, and the sidewalk into unique patterns, because that word minimum is in every ordinance on the planet. So it implies to go beyond the minimums. And you can see that here. So if we look at the length of street, we've got 3,333 linear foot of street, which is almost 1/3 less street. And then when you look at the impact, even though we have a community center, average larger home size, and alleys and guest parking, we're still about the same as the grid pattern, even though we added all this extra pavement and have longer driveways, which is in your ordinance. You want that 25-foot setback so you don't park over that sidewalk. We have even greater setbacks. So what do home buyers really want today? They want walkability. They want to be in a suburban neighborhood that likes some parks. I live in a grid, and my home's here, and if I want to walk to the park, I got a straight line. I also have 2 restaurants within walkable distance of my home, but I'm not going to walk it because I can't walk directly to those restaurants. I have to walk way out of my way because of the grid. So the grid is thought to be walkable, but is it really? We can use different elements to actually increase the walkable connectivity and the safety. So this example, wider trails used for emergency vehicles. In this case, in this neighborhood, we're using the alley so that we could cut through the block, but we could also walk through the block to that community center. The extra deep setbacks that create that park-like setting allow us to meander walks and put them in easements as they go outside the right-of-way to create these exciting, beautiful neighborhoods. And we don't have to cross at the intersections. We could pull away to make neighborhoods much safer. And you can see if you're walking through this neighborhood, these elegant meandering walks encourage a stroll over a drive. Again, they're set in easements as they pull outside the right-of-way, so they're still public walks. Plenty of space for the street trees to grow, and it creates this park-like setting instead of this corridor of garage to garage. Walks are great. You know, if the weather's fine, you have time, you're physically able, and you're not too old. We have to create better drivability in neighborhoods. So when we look at the physics of getting that car in motion, they don't instantly go to 25 miles an hour. They take about the amount of time shown here to get to 25 miles an hour. It's about 200 feet to get there and about 200 feet to come to a stop. That's incredibly inefficient for both time and energy. So that distance of about 400 feet is what we call flow cycle. The more flow cycles you have, the less efficient it is to get home. So this is just an example, a good before and after example. It's very similar to this neighborhood. So when you look and you start tracking distance, you have to be over 400 feet to get to this efficiency. In this neighborhood, for almost every home, you're never getting up to 400 feet, so you're going to blow through intersections. You're going to hit that gas and that brake harder. And there's no street that defines the neighborhood. So we want a street that defines the neighborhood. When you look at the before plan, you have these straightaways, and in your ordinance, there's all kinds of things on there for traffic calming, and you know, on a straight street, you got speed bumps, you have all these things that are negative. You have side yards, you have rear yards exposed as you drive down the street. You're going to have to slow down through that curve, and then you speed up again to get home, and that process never goes away, and then you've got this narrow corridor of street. So when you look at the alternative to the plan I just showed you, what we're trying to do in every one of the neighborhoods is have a main street that defines the neighborhood and has a park-like setting. And so when you enter the neighborhood, you're maintaining flow throughout the neighborhood. And that will reduce the average time and energy through the neighborhood, and that never goes away. Also, that efficiency. So, like the example before and after, we have almost the same results. But there's more to this. As you drive through these neighborhoods, it creates that park-like setting. It's a completely different feel than the straight street. The curves we use, we've been doing this for 36 years. We've got 1,700 neighborhoods in 48 states and 18 countries. We've experimented over the last 3.5 decades with radiuses. We found a sweet spot at about 200-foot range for the radiuses that are safe. They slow down traffic. You don't need speed bumps. It creates an elegance, and so that's what we're using on pretty much every neighborhood for the last decade and a half, 2 decades. You can see that there's no home rears that you see. It's all home fronts, very few sides, and it creates more of, when you look at the neighborhoods of the past and the urban areas that are so warm, it's because you've got a front-to-front relationship. In the suburbs, we are exposing typically too many rears to the street and too many side yards to the street, where right now there's very, very little. That one street maintains flow. Look at that space. That's a cove you see right there. So as we're undulating, we're also reducing that monotony in the development. So then I want to talk to you a little bit about the experience of being in your home and looking out that front window, being on your porch, looking at the streetscape, being also inside the home, looking at that more space on that rear yard. That experience of actually being in your home, tying the interior space to the exterior space, is also something that's probably not in any ordinance purpose and intent, but it should be. That goal of heightening that. And then when we look at the alleys, these aren't your typical alleys here. There's tons of space there. We're using that cut through to reduce a distance for an emergency vehicle, but also to connect you to walk over to the community center. That's more central to the neighborhood in that spot that is very serene and quiet in those backyards. So this is why we put the community center there. Again, the before plan didn't have a community center. And even though we have longer driveways, added alleys, added the community center, average bigger lot size, we're about the same environmental impact as the grid neighborhood because we are reducing the waste elsewhere. So when we look in conclusion at what we're accomplished here, when you look at the purpose and intent of the regulations and what we have done and we propose, we're using these new techniques and the new technology to advance neighborhood design so that we exceed the purpose of your intent.